Here's a problem from 11.5. You have to find the following power: 3 square root of 2 minus 3 square root of 2i raised to the 8th power, and write the answer in rectangular form. Do not use a calculator. Okay, the first step is we have to find r. So r is the square root of x squared plus y squared, which in this case would be the square root of 3 square root of 2 squared plus negative 3 square root of 2 squared. So 3 square root of 2 squared is equal to 9 times 2. And the negative raised to a second power becomes positive, and that is also 9 times 2. So r is equal to the square root of 18 plus 18, which is the square root of 36, which is 6. Now, which quadrant are we located? We have a positive square root of 2 over 3 square root of 2. So let's just say that's right here, and we have a negative 3 square root of 2i, and I'm gonna sketch this right here. So we are in quadrant 4, and this is the angle we're looking at. So the tangent of theta is equal negative 3 square root of 2 divided by 3 square root of 2, which is equal to negative 1. So the angle in quadrant 3, therefore, is 7 pi over 4. So now we can use the Morph's theorem and write this complex number in trigonometric form. So that would be 6 times the cosine of 7 pi over 4 plus I sine 7 pi over 4, all raised to the 8th power. So using the Morph's theorem now, we are applying it, and we raise 6 to the 8th power times the cosine of 8 times 7 pi over 4 plus I sine of 8 times 7 pi over 4. Okay, I'm going to use my calculator now. 6 to the 8th power is 1,679,616 times cosine. Now we can reduce. 4 goes into 4 once and into 8 twice. So the cosine of 14 pi plus the I sine of 14 pi. Now the sine of 14 pi is equal to 0. So this is 0, and the cosine of 14 pi is 1. So we get 1,679,616 times 1 plus 0i, which is equal, now in rectangular form, 1,679,616 times 1 distributed, and of course times 0 is 0. So this would be your answer in rectangular form.